Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. And in today's session, I'm going to continue section 1 of the AP Calculus BC. We did 20 problems before, and this first section has 28. So now I'm going to go over the next 8 problems. In problem number 21, it says find the derivative. So they give you f of x and they want f prime of x if this equals e to the sine square of x. Okay? And of course, they give you the answers. Here you can see that we will need to use the chain rule. As we said before, I think I have a whole session on the chain rule. When you do f prime of x, the first thing you encounter when you read is e. And you know that the derivative of e to the x is e to the x. So when you take an e to something, you assume that this thing is x. So you say e to the sine square of x, as it is. And then you step inside of the e, you see sine square, something square, like x squared. The derivative is 2x. So the derivative of sine square of x is 2 sine x. Then you take away the square. Notice that sine, that's basically is e raised to the sine of x quantity square, but we write it sine square of x, so nobody understands that the x is the one that's squared. It's the whole sine that, but basically it's written like that. So the first thing you encounter is e, and the derivative of e to the x is e to the x. So e to anything is e to that thing. And then you go into that, you see something square, x square, its derivative is 2x. So anything square, its derivative is 2 times that thing. Then you go inside of the square, inside of this bracket, you see sine of x. So you multiply it, you get cosine of x. And that's basically it. It's very simple. And again, if that was 3x, not x, I would go inside of the small parentheses, I see 3x, the derivative of that is 3, and I would multiply that by another 3, and it would have been 6, for example. Now, and you can see this is a. Here is the 2, here is the e sine square, here is the sine, here is the cosine, so that's a. So that's an easy one. Let's go to number 22. You are given x and f of x. I don't know if you can see it. The numbers are so small. I'm not sure if they are. So here you have x is 0, 2, 6, 7, 9, 12, and 16. And f of x is 1, 3, 7, 5, 3, 6, 9. And they tell you, use the left hand Riemann sum, left hand, with this within these 6 subintervals to approximate the integral from 0 to 16 of f of x dx. Remember, the left Riemann sum is that we assume that I have a rectangle and its height is the number on the left. So it's like, okay, here is the 0, here is the 2, here is the 6, and then at 0 you get 1, and then, I'm sorry, this is, yes, and then at 2 you get 3. So again, I don't have enough space, but I want just to show you what's going on up here. So basically, the height is f of x, the one on the left. So I'm going to take this rectangle, and then this rectangle, and then that rectangle, and add them up. If it was a right Riemann sums, then I would start with the 16, and when I come here, maybe you use a different color, it would be, the height would be 7, and here the height would be 2. Okay? So basically all what we have to do is to say the distance of 2 times 1 plus that distance is 4 times 3 plus here the distance is 1 times 7, plus here the distance is 2 times 5, plus the distance is 3 times 3, plus the distance is 4 times 6, 24. You get 2, 14, 21, 31, 40, 64. It's just addition, so no big deal. 64 is D. I don't know, I didn't do it, but usually they would give you an answer if you use it from the right. So maybe if you use this as the height of the rectangles, it doesn't look like that, but usually they will give you one of these answers. So those who are doing it incorrectly, they will get something they think it's correct. Let's move to number 23. That's a typo, by the way. I did it. And this number should be a 2, not a 9. So you want to integrate 18x squared plus 2 over 3x cubed plus x dx. And I told you, I'm sure at school, if you have something like that, you usually use substitution. So you would say I don't use substitution, but I say I will tell you what I did. I think I discussed that in one of the sessions. Let u equals 3x cubed plus x. So du becomes 9x squared plus 1 dx. Now you see the numerator has 18 and 2, so I can factor out 2 and say this is the integral of 9x squared plus 1 over 3x cubed plus x dx. Now this quantity right here, 9x squared plus 1 dx, is du. So that becomes 2 times the integral of du, and 3x cubed plus x, we already said this is u. So you get 2 natural log of u plus a constant, but u is that, so you say 2 times the natural log of 3x cubed plus x plus a constant. And that's E. 2 natural log of 3x cubed plus x plus c. So the answer is E. As I said, I don't use substitution. When I take the 2 out and I get this guy, I can call that, and probably you would use that later when you become more confident, or yeah, some of you already know. This guy, 9x squared plus 1, is the derivative of that. So I can write it as d 3x cubed plus 1 over, plus x over 3x cubed plus x. And the integral of that is the same as the integral of du over u, because that's the derivative of that. But again, let's play it safe. Again, here there is nothing safe in it because you don't have to show your solution, so you don't really need to use the derivative, the substitution. But that's basically how you learn how to do it. Okay, let's move to number 24. Number 24, you want to integrate e to the x sine of x dx. And I covered the integration by parts, had a whole session on that. And I told you what happened if you have one of the functions that are multiplied is periodic, keeps going, sine, cosine, then negative sine, negative cosine, and then sine, cosine, and so on. It repeats. And the other variable or the other function, e to the x, stays the same. So the easiest way to do it is to call this I. Okay? And then you say, here is the derivative, here is the integral. And again, in this case, it doesn't matter which is which. So let's say I'm going to take sine of x is the to be the derive, meaning I get its derivative. Excuse me, I can do the other way around. And this is e to the x. So the derivative of sine is cosine of x, then negative sine of x. And this is stays e to the x forever. And like we said before, we multiply these two plus these two times -1. And then I stop here and I'm going to say, then I will integrate that. Let's see what we get. We get e to the x sine x minus e to the x cos x minus again e to the x, the integral of e to the x sine x dx. Oh, but this is the same as that, which I can write as minus I. This is I. Now, when I move it to the other side, I get 2I equals e to the x. You factor it out, and you get sine of x minus cos of x. So I equals this whole thing over 2. Divide both sides by 2. That's how we do it when we have a periodic function, and that's basically A again. Oh, no, that was E. DE, and then this one is A. So sometimes you give you instead of negative, they give you positive, or they don't divide by 2, even though this is twice I, and so on, or they give it, but they switch the cosine is positive and the sine is negative. So different combinations, and you have to pick the correct one, of course. But that's a quicker way of, instead of, saying let u equals e to the x and dv equals sine x dx, and then you do uv minus, and then you do another, it's a long way. So the tabular form is quicker, of course. All right, so that's number 24. Now, we still have 4 more. So let's go to number 25. And see what we have. 25. Which of the following integrals converge? The first one is integral from 0 to infinity dx over 1 plus x squared. Of course, that's an improper integral. So usually we have to say limit as b approaches infinity, the integral from 0 to b of dx over 1 plus x squared equals the limit as b approaches infinity of arctan of x, right? 1 over x squared. And it goes from 0 to b. When x equals b, which approaches infinity, we know that arctan of infinity is pi over 2, right? Pi over 2 minus arctan of 0 is 0. So it converges. So 1 converges. Let's look at 2. Integral from 0 to infinity of dx over 1 minus square root of 1 minus x squared. Well, again, you can do the limit. Of course, when you solve, since you're not showing work, you don't need to do that. You can simply say it's dx over the square root of 1 minus x squared equals the limit as b approaches infinity of arc sine of x evaluated from 0 to b. But when b is infinity, this thing is undefined. So we say it diverges. So it doesn't converge. What about the third one? Integral from 1 to infinity of dx over x. Again, we are not wasting our time by writing what I'm doing here. I'm just showing you. If you had to show your answer, that's the way you do it. You know, the integral of dx over x is natural log of x So it's natural log of x evaluated from 1 to b. When b approaches infinity, natural log of infinity is infinity, so that's will diverge. So only one, meaning A. The answer is A. Alrighty, next one, 26. Number 26, it says find the area of the region in the plane enclosed by r equals 5 plus 2 cos theta. Okay. So again, you don't need to plot it. We know, do you know what that will give you? Riemann Sums? Anyway, so when theta is 0, you get 2, cosine 0 is 1, so 5 plus 2 is 7. When you go to pi over 2, that would be 0, and you will go to 5. And then when cosine theta, when theta is pi, you get negative 1, so you get 3. And then 3 pi over 2, you get 5 again. And in fact, since this is cosine of theta, the idea is that you go from 0 to pi to 2 pi. Because sometimes if that was 2 theta, for example, you need to make sure you are integrating to pi only. So basically the idea, we know that the integral is shaped like in polar coordinates, we say the area is 1/2 the integral of r squared d theta, right? So because if I have something like this is r and this is d theta, right? This distance would be r d theta, and this would be a triangle with a base of r and a height of r d theta. So its area is 1/2 r d theta, or 1/2 r squared d theta. You integrate to get it from 0 to 2 pi. So that becomes 1/2 the integral from 0 to 2 pi of 5 plus 2 cos theta quantity squared d theta equals 1/2 times the integral from 0 to 2 pi of 25 plus twice the first times the second, which is 20 cos theta, plus 4 cos square theta d theta. We know that cos square theta equals 1 plus cos 2 theta over 2, right? So this would be, you can say the integral, if you want to do it 3, I mean, you don't have to, 25 over 2 d theta plus the integral from 0 to 2 pi of 10 cos theta d theta, and 1/2 times 4 over 2, so that's plus the integral from 0 to 2 pi. Notice what we have. 1/2 times 4 is 2. 2 times that is just 1 plus cos 2 theta d theta. The integral of that is 25 over 2 theta evaluated from 0 to 2 pi, plus the integral of that is sine theta 0 to 2 pi, plus the first one is theta, the second one is sine 2 theta over 2 evaluated from 0 to 2 pi. Now, I don't care about the 0 because everything would give me 0, right? So I only need to evaluate at 2 pi. So 25 over 2 times 2 pi, the 2 and the 2 cancel, and you get 25 pi. Plus, sine 2 pi is 0, sine 0 is 0, so this is 0. The integral of that is, I'm sorry, the theta, when you evaluate it, you get 2 pi, and then sine 4 pi is 0, and sine 0 is 0, so plus 0 equals 27 pi, and that's E, the last one. Okay? We move next to the last two questions. We have number 27. Okay, 27 looks easy. It says dy dx equals cos x over y squared, and y of 0 is -1, meaning when x equals 0, y equals -1. They give you that, of course, because when you solve this this equation, okay, you have to cross multiply, so you get a differential equation, y squared dy equals cos x dx. Then I'm going to integrate both sides. I get y cubed over 3 equals sine x plus a constant, right? You say, why didn't you add another constant at the yeah, I can call this C1 and this is C2, and then I subtract them, I say the difference is C. So it really doesn't matter. In fact, I'm going to multiply both sides by 3 since they give you the answer. So let's call that C1, because I know some people will say, oh, why, how do you multiply C by 3 and you still get C? Okay, so this would be 3 sine of x plus C. So I'm going to call 3C1 a new constant that I'm going to call C. And oh, I'm sorry. Yeah, I didn't do that. Okay, so they tell you when x is 0, y is -1. So -1 cubed equals 3 times sine of 0, which is 0 plus c. So c equals -1 cubed equals -1, and then you substitute back. So you say y cubed equals 3 sine of x minus 1. You need to have the constant. I forgot that they give us that. So that would be A. 3 sine x minus 1. Finally, we have number 28. So I'm not going to use a new paper. What I'm going to do is to just turn it over and do number 28. Number 28, they said, okay, which of the following series converge? I is the summation n going from 1 to infinity of 2 times 1/3 to the n minus 1. Right there, you can see that's a geometric series, and or the multiplier here is less than 1. The absolute value of it is less than 1, so it will go to 0. This converges. How about the second one? The second one is summation I going from 1 to infinity of n over 3 to the n. Well, you can use the limit comparison or the comparison test. So you take the n plus first. So you say you're going to take the limit as n approaches infinity. The next one is n plus 1 over 3 to the n plus 1 divided by a to the n, meaning I'm going to reverse these and make them 3 to the n over n. So that becomes the limit as n approaches infinity of n plus 1 over 3n. Right? And then when you divide top and bottom by n, you get 1/3, and 1/3 is less than 1. So this one also converges. The last one is the summation n going from 1, I say I here, and going from 1 to infinity of 6n squared over n cubed plus 1. And this one eventually would go to 0 as n approaches infinity. So we can use the integral test, meaning I can take the integral from 1 to infinity of 6n squared over n cubed, or x squared over x cubed plus 1 dx equals the limit as b approaches infinity, the integral from 1 to b of 6x squared dx over 3x squared plus 1 x cubed plus 1. Okay. Again, you can say let u equals x cubed. I don't like that, but you can say let u equals x cubed plus 1. Then du becomes 3x squared dx. So this is really 2 times the integral of 3x squared dx, which is du, over 3x cubed plus 1, which is u. So that becomes 2 the natural log of u, meaning 2 the natural log of x cubed plus 1 evaluated from 1 to infinity. But when you substitute natural log of infinity, you get infinity. So this one diverges. So 1 and 2 converge. Again, you don't need to do all this work. You just find out that the derivative of the denominator is half of the numerator. So you can say 2 natural log, natural log of infinity is infinity. So you don't need to show any work. I'm just showing you how to prove it if need be. So D, 1 and 2, right? D is the answer. And that concludes the first part of, or section 1 of your exam. Next time, we'll start section 2, which also has multiple choice, but it allows you to use a calculator. Okay? Until then, I wish you all the best and hope to see you soon. Bye.